to our exciting panel on the future of data storage in the age of AI. Um, I do think it's kind of a one of these topics that could get very deep and technical, but also can be very practical. And I think we have a very interesting group of panelists here that can all shed unique perspectives on where we are today, where we're going, the challenges around this. And I know data storage, this can mean a lot of different things, right? We could be talking about the cost of storage infrastructure all the way up to the importance of privacy and how you retain data sovereignty, if such a thing even exists. And I think there's a lot of ground to cover. So I may periodically interject with an occasional question or deep dive where I want to poke at something a little deeper. But in the interest of time, because we do only have 1 hour here, and we have a pretty serious and interesting group of panelists, I think we can dive right into things. And probably I'll let us kick off with Dr. Satyam, if you want to give us a quick intro to your thoughts on the subject and where your concerns and aspirations and views are taking you in regards to this.
Absolutely. Okay. Why is my video gone somewhere?
It disappeared the minute you start talking. You're back now.
Interesting. So if you look at the evolution of data storage or and look at the bigger picture of data centers, right? Data centers are the bigger picture of data storage. But if you look at it in the last 20 plus years, it has not grown exponentially just from a traditional aspect, because people have been storing data that now when the age of AI came and they said, oh, data is not of good quality. So that will address to your question of cost related to data storage. So if AI can't use the data, then why are we storing? That's question number one. But in order to really build meaningful models, and if someday, true to its definition, if we are able to build what is called self-learning models, that means we would require real-time data as it comes in, and the models will get actually updated by itself within the right governance framework. That certainly requires significant amount of energy, and that means how do we now really balance the cost of energy to the data stores that we need when it comes to real-time data. The third area is, which is now closer to my heart and from last 34 years, is now the evolution of quantum computers. And those themselves will consume so much energy and generate so much data that I don't think anybody has actually forecasted that very well. So if we look at in these three kind of eras, pre-AI, current AI, and quantum AI, I think we are in a, what should I call, in a shock of how do we actually navigate this landscape.
Doctor, I got a question for you.
Yeah.
So regarding your second point and the data being stored and also the quality of the data, do you think that the issue really stems from the fact that the data centers housing a majority of the information, like petabytes of data, and the processing for those things? So you have to cache them, process, and then remove those caches so that you're not storing things which are unnecessary. But the vast bulk of it seems to have redundancies in it, and the power processing has to become that much greater because there's no communication between the actual data stores. Now, say, for instance, let me take this example a little further. You have, say, 3 major LLMs. Each of these LLMs has their own bank of information, petabytes of data, which they're learning and training off of. Now, in the tenets of Western commercialism, the idea is that we want to have some sort of proprietary nature to our models. So in order to have that, we need to have our own data sets. We need to analyze them a specific way. What gets analyzed and then produce, the data from the data, then also has to get stored. And because there's a lack of communication amongst these things, you have siloed data sets. So each person is amassing up these huge stores, which require a ton of resources. And they're also lacking communication amongst each other because they're not really cooperating in nature to say, hey, I understand you have this data. This data is really not of a necessary value. We could probably scrub this altogether. And if we communicated and moved past the idea of IP protection and really tried to work as a total unit to reach your phase 3 you talked about, which is that artificial general intelligence, the only way you could do that would be really an unsiloing of the data structures themselves and creating one continual real-time pool of information that all of these models would pull from. Would that not be correct?
Yeah, so you remember about 30 or plus years back, there were a lot of discussions in the business world called co-optation, right? Competition, but at the same time co-innovating. That method has kind of got lost in the process, and as a result, forget about industry cooperating or co-innovating. If you look at bigger companies like, let's take energy companies. Within the companies, you will find redundancy in the data, right? And even because that's the nature how we have become in terms of like storing data, we have become in such a way that we will store the same calculated data in 5 different ways and we won't share with each other. This is a practical example which you can just extrapolate to companies. And this, in fact, in the last 10 years, I was in energy industry. There have been people who have said that they have 7 copies of the data.
Yeah. So
right?
I guess I would.
So if you think of it, then if you really want to reduce the cost, and if people are really serious about, call it energy transition net zero, then they really need to cooperate together to, especially how the data is used. There is no, if you are consuming the same set of data for LLMs, as the major ones are, then there is no reason why they should have multiple stores of that.
I agree.
And they can try to cooperate, and they can have their own what you call proprietary models associated with it in the way they do the calculations. But in terms of data, they can reduce that cost significantly. But unfortunately, people talk about energy transition, but not serious about it.
So then I guess this boils down to a simple fact, and I leave this open to the whole group as a question. Is this really a data storage issue, or is this a human communication issue?
I think that is a good open question. But before we dive down to that, I'd like to sort of finish going around the horn, if we will, and see if we have any other topics that people want to bring up. And let's, Rahul, you want to jump in here and give us your initial thoughts on the topic?
Yeah, I've been in data centers, managing as well running data centers for last 25 years. What we have seen is the consumption of energy has gone up, especially with the GPUs coming in. It has increased a lot. On the secondary note, what has happened is there has been a lot more advancement in cooling technologies, from forced air to water cooling and all of those things, which are bringing some of the energy costs down. So when we are talking about the future is of data centers as well as AI coming in, the GPUs getting used. A lot of energy is going to be the main concern, more than the storage. So we have to start really looking at how we provide that kind of energy or consume that kind of energy. Look at the cost basis analysis of running a data center or running servers in a typical form fashion, and what is the cost behind it to do these kind of things. So that is where I am more seeing where the future of data centers and AI coming into play is. It is going to be a major hog on energies. And how do we save it? Or how do we lower the cost of energy into this thing?
Well, I don't mind responding.
All right. Welcome aboard, Giovanni. And by all means, jump right in.
I'm the portfolio manager to a single family office. I am very concerned about energy. I live in Monaco, where Their fear was that with the Nord Stream pipeline being shut down, that there would be brownouts and blackouts in Europe because of absence of natural gas. This led me to a family office that's in Tulsa, Oklahoma, which is George Kaiser Family Foundation. They own Bank of Oklahoma, Williams Energy, Bank of Albuquerque, Bank of Texas. Because of a connection, I got introduced here in Tulsa, Oklahoma, and I was very interested in buying the dip in Bitcoin, and I sort of went down the rabbit hole of data centers, primarily because of the cost of power. It has been my experience that there is a ton of wasted energy. So where there are sources of energy versus where there is the need for energy, there are sources of energy tend not to be where there's a need for energy, and needs of energy are not where the source of energy is. So I have focused on Bitcoin mining because within the sort of global landscape, let's say, of data centers, you have, let's say, edge computing and quantum computing, and let's say Bitcoin mining. What I have found with Bitcoin mining is that I am able to bring the need for energy to the source of energy by putting those data centers in cargo containers and taking them to the source of energy. I think what makes America great is government waste. There is no such thing as a billionaire in America that does not stand on the shoulders of America, of the American government, of government waste. There is no way that Jeff Bezos and Elon Musk would have created rocket ship companies if it were not for the fact that NASA, quote unquote, wastefully shut down the space shuttle program and made a whole bunch of rocket engineers redundant. And then at the same time said, well, why don't you go build rocket companies and we'll give you the contract? So these billionaires didn't have to pay for employee training, and they had a clear path to revenues with the government. Okay. So I love the fact what the Inflation Reduction Act has done, which is that the American government has said that the stick approach to punishing people for polluting the environment is not affecting the desired changes we want from avoiding pollution. What if we use the carrot approach? And so the Inflation Reduction Act says no one knows better how to stop polluting than the polluter themselves. So polluter, stop polluting and then prove to us that you have stopped polluting, and then send us the bill and we'll pay you for not polluting, right? And my job in the family office is to make money out of other people's stupidity. And what I have found, right, is that the canary in the coal mine are Republicans. Republicans and conservatives they live their philosophy, which is that government screws everything up. So when the government said we're going to employ the Inflation Reduction Act, oil and gas companies in Texas did not believe that they could count on the government. And so I went to these people, I went to oil and gas companies, drillers, and said, you're fracking for oil, I'll take your natural gas, I'll take on the liability of the Environmental Protection Agency, I'll stop polluting, I'll submit the bill to the federal government. Now, it hasn't happened yet. We're in the process of doing it. We have not been paid by the federal government. But I have found, I believe, that we can solve the energy problems that are perceived to be coming down the pike with data centers by not putting data centers, in Virginia close to the client, right? But putting the data centers close to the source of power, not the source of the client. Okay. And it is easier to transport data down fiber optics than it is to transport electricity down high tension wires. So I do believe now, something that Rametra said, I disagree with an element of what he said, which is that liquid cooling is not cheaper to cool, because it's actually way more power intensive than air cooling or evaporation cooling. It's just that when you have an access to abundant cheap energy, it is more efficient to clock your ASICs and your data center, so as to achieve more productivity out of your data center, consuming more power at a cost of power that is significantly lower. Last point that I'd like to make is, I think that history is repeating itself, and where we are today is sort of, let's say, the 1910s, 1920s with the automobile. We're getting far more efficient at transportation. There is an abundant source of powering that source of transportation. And I think today we're still not valuing energy enough. I think energy prices should be significantly higher, because you got to look at the opportunity cost, which is, if you put a gallon of gas inside your car, you can travel 30 miles, 4 people plus luggage for $3, let's say, or let's say $5 or $6 if you're in New York and LA. You can't go 30 miles with 4 people and luggage on a rickshaw or a horse-drawn carriage or whatever, right? It's going to cost you hundreds of dollars to do that. So the alternative to a gas-powered car or an electric-powered car, right now, energy is way too cheap. Fossil fuel energy is it's so abundant right now. It's getting scarce, but it is so abundant that we are undervaluing that power. So in that context, in a race to the bottom for the cheapest source of energy, there is tons of wasted energies around hydro plants, because we're trying to move the power from a hydro plant to where it's needed. What we should be doing is moving data centers to the hydro plant and then transporting that data across fiber optics. So I think there are incredible opportunities in this space. And I think that what's actually happening is, right now we're solving a lot of problems with brute force computing. And what we're underestimating is how efficient computer processing will become, and so how significantly less we will need power to achieve that same processing. But at the same time, processing demands are, I don't know, it's yet to be determined if they're outstripping the increases in efficiency of processing. So, my role here is to put my money where my mouth is, and that's where I'm putting my money. That's my conviction.
That's a pretty good conviction, and actually raises a whole bunch of interesting discussion points that probably could be a panel in and of themselves on markets and energy dynamics and pricing and the history of all this. I do think broadly we are seeing a trend of data centers moving to where the power is, and I think that kind of started in the with the miners on the Bitcoin side of things, and with AI, we're seeing that a lot of the energy is needed in the training side, which is less important to be near the edge. And so there's a capability to move it farther away from the edge. But I do feel this is all a little bit kind of energy centric and less data centric. And so I want to put that on hold. And like I said, take it back to another conversation. And let's switch over to Lance for a minute and see what he has to throw at us.
Thanks, Chris. So I'm Lance Reich. I currently work for the State University of New York. I'm a patent attorney. I've been in the field for electrical engineering and computer science for 35 years. I also consult as a chief technical officer for a startup. And we're on the security side of data. And for us, the problem was basically the internet architecture that started the internet and then moved to the cloud architecture, which is now wrecking the internet. So we believe that if you can bake security into data in a data storage system from the get-go, from the moment it's intended to be stored, you only have to do it once. You will not have to worry about security, the entire path the data takes, where it's stored, what goes, and then when you can retrieve it to the client for use, whatever use it is, that's it. And when you do that, it lets you change the architecture of a data center and cloud in general tremendously, because you can then pull apart processing and storage. Okay. And when you, as Giovanni was so eloquently talking about, the processing is the monster. Storage is not the monster. Storage is the volume monster now. And AI is both trying to solve and causing that problem because it needs larger LLMs. It needs more and more data, but it can also optimize. It can self-optimize and structure itself for storage in a better manner. So it's both giving and taking on in that way. But for us, the key is, if you pull apart processing and processing needs from storage and storage needs, and you don't have to put storage into the hyperscale architecture where everything is hot, where all the energy is being used, where you need to store petabytes and exabytes and all these levels of data, you're making a huge savings all across the board in storage costs, operation, heat, energy. So I think that the next breakthrough here is going to be, perhaps it's us, perhaps it's someone like us, where you say, okay, let's re-architect the system. The internet was not created for security. It was created for file sharing and access. The cloud system that we have now was created for the cloud providers and their benefit. They don't like security. Security is a roadblock. And they view data breaches, which is now 82% of data breaches, according to IBM, are in the cloud. We're going to wait till it's 99%. And so, but they view that as a cost of doing business, rather than, maybe we should help our users keep their data secure. So I think that seems like a simple solution, but if you do that, a whole bunch of changes will cascade with cloud architecture, with the possibilities of edge computing, and also with just savings and energy, environmental impact. So that's my side of it, but it's a big change caused by simple security in the front. Thank you.
Yeah. Folks,
You
can I
go ahead,
comment on
Alexander.
this?
Sorry. Go ahead.
So this conversation seems 2 to 3 degrees removed from what the actual issue is. I don't think we're taking a first principles approach here, and I'm going to be honest. Moving data centers closer to energy is like saying I'm going to put vaccines closer to people and assume they're going to use them, and that'll fix the problem. That's an absurd notion. We've done that many times with a lot of things in history, and that won't work. Now, if we look at this ramp up of the vast amounts of data that we're analyzing, and that creates a vast amount of processing power, which requires energy to the GPUs, we have gone down the path of having to consume a higher volume of data, essentially fuel, to use to do the processing. But it hasn't given us the output of quality that we're looking for from the data coming from these data centers using systems like LLM or other machine learning AI models. So the principle we should be looking at is the choice of what we're actually choosing to analyze and store. So if your GPUs are the issue and they're the most expensive, well, then you should be very diligent about the data intake that's coming in that you're choosing to store and how it's being analyzed. And to double down on Lance's comment, your system, what you're talking about, is a temporal data storage built with security. So it's pre-encrypted at a point coming into the front, and hopefully in the future when homomorphic encryption. And what that means is you can keep things encrypted but still get access to the data without breaking the security structure. That's something that's close down the road that even our firm currently works on. But the temporalness of it is going to be very important, where we as human beings need to come and choose what are the most important things we actually want to store and study that will give us the best evolutive outcome for artificial intelligence that we as human beings are using to evolve ourselves. So rather than look at the energy problem, the energy is there because we think it's in our best interest to consume more and more of this data to hope for a better outcome. But we all know who's had that famous quote, Einstein, do the same thing over and over, right? So for us, it shouldn't be about the vast volume and energy we're spending, but pause for a moment to think about what we're actually choosing to store and analyze, especially if the resources are so precious around those GPUs. Do you guys follow where I'm going with this?
Yeah, I think it's absolutely a valid question. And I think, looking from your perspective on what we're choosing to store, how many redundant copies of what we're choosing to store, what actually matters, looking at questions like the internet architecture and where data is going to be accessed and how it's going to be accessed, looking at energy costs, quite frankly, whether it's as moving data closer to the energy or not. These are all really deep and interesting topics, but I kind of feel like that we're all approaching it from an outside perspective. And now that we've kind of hit on a handful of these different items, Amanda, do you want to jump in here from the AI company side and talk about how you think about or respond to each of these things?
Yeah, I think some very valid points are made. For example, just to touch on it, what is actually even practical for AI companies to be using in terms of, model architecture that directly impacts, whether it's energy consumption or just monetary costs of GPUs. Like I can tell you from a company that I own, which is basically in the data redaction space, the document redaction space. All we're dealing with is, sensitive documents of customers that, again, I think to Alexander's point in the beginning, have to do with like the human communication and how we're communicating to this customer, how we're storing their data, how we're using and utilizing sort of security, first approach, to our architecture. But also on the AI side, we had to determine, are LLMs practical for our particular use case? Or do we have to use, what some people call more outdated architectures like BERT models, for example, to process all of that data as it pertains to consumption and cost. And for us, we determined that LLMs were way too expensive to run on GPUs to process, thousands and millions of pages of documents. And I think that's where a lot of companies are going to get to that point as they run their POCs with, some of the big consulting companies, and they realize how truly expensive. While there's a lot of good work that's being done, it's just not practical AI. And so I'm much more of an advocate for like what is practical cost-wise, consumption-wise, and for your customer, because a lot of the times they don't need as sophisticated technology as everybody wants them to need. Sometimes they just need things that are just getting the job done for their enterprise workflows.
Yeah, I think that's something we hadn't really touched on is the different kinds of AI and different use cases. And I definitely think that's a very valid question for every enterprise out there, and actually probably for lots of individuals as well. One thing that nobody's really spoken about yet, and maybe we don't have an opinion about it, maybe we don't have the right person in the audience, but I'm curious if anybody wants to jump in about data rights and something that has been huge over the last 20, 30 years in terms of social media, something that's been huge over the last 100 years in terms of intellectual property law. As we move into the world of data training and AI and perhaps more collective open source integrated data models, how do we think about that? Is there an impact there that we need to care about? Is that out of scope for this group, or anybody want to raise a hand? What do we think?
What my company does. So I guess I'll take that. Not that I want to bogart the airtime. Our system's called Turtle. We instituted the world's first publicly trading data marketplace for consumers to vault their data and then permission that back with consent and licensing to companies who want access to that data. It's the inverted model, things that happened post-Cambridge Analytica. So when you talk about the data rights, uses, and permissions, I would want you to imagine that the AI companies or LLMs that come to us now ask us, hey, we've run out of data. Our synthetic data is weak. It causes our models to crash. We need proprietary zero party, so directly from the Chris or the Togruls or the Dr. Satyams. We need their data directly with their permission to get these longitudinal data sets that are incredibly novel, which are rich for us to train off of. So what you're seeing now is there's an established relationship between those ones who are ingesting the data into these larger models and the public is training them and essentially receiving that cash royalty for their participation in sharing the data to train those models themselves. So we established that marketplace framework between consumer and business to do that thing. And we carry the temporal structure that Lance was talking about at the earliest stages of homomorphic encryption to reduce the energy costs and the redundancies required, but allow us to support millions and millions of data vaults of people with their own sovereign ownership over it to then choose to permission that into systems to train, which inevitably they will use or will be, baked into some technology that gets used for them. Do you follow?
Yeah, I mean, I follow the technical discussion and I follow the demand side of that equation, where for sure the training companies need this data. I am a little curious about the marketplace side of things because I don't know. I mean, I get why consumers would want to sell their data and monetize it. Why wouldn't you? But it seems like it might not be an easy transaction. There might not be an easy it might not be easy for the average person to get their head around that and figure out how to engage with it.
Yeah, we made it seamless, and I know others want to talk, so I'll clarify this and then shut up. We wanted to make sure that we reduce frictions as much as possible and bury the aspects of complicated technology in the background and make it people feel like they're just doing an Amazon transaction. It's literally that
Nice.
simple for the sourcing and permissioning of that data through our marketplace.
All right. Well, there are a lot of hands up, so let's go with Tagro because you haven't spoken yet. We'll let you get in here first.
Yeah, so I would actually like to expand on Alexander's point here about, and your points, Chris, specifically about the sources of data that we're consuming and the systems that we are using are consuming. So I'm the head of AI at Polygraph, and we have a product where we essentially enable people to see where the exact data that they are using, that they are seeing an LLM or a large language model generate are coming from. So just because somebody generated a content through generative AI doesn't mean that they own the rights to it. So in my belief, it is actually important to provide the tools to the people for them to understand what is the source of the data that I'm looking at. Because whenever, for example, I'm reading a research paper or reading a news article, I want to go down that rabbit hole and see the exact, let's say, source of that information to see whether I would like to believe this or not, and whether this is coming from a trustable source. So another perspective sort of to take here is not only that we would like to have large language models capable of understanding, evaluating, and generating meaningful text, but also to see where the inspiration in the source data comes from. Because only in that manner can we actually make people who are not the experts in the field not be ingesting flawed data or flawed information generated or hallucinated by large language models. And this actually also brings me to another point about the cost and the energy consumption when it comes to training those models as well. So I've been involved in the research part of both the hardware and the essentially models architecture perspective with even folks from Google. And what I'm seeing in here is the redundancies when it comes to not only storage of data, but also the hardware used to train the models, GPUs, and also the architecture of those models. So a recent model, for example, DeepSeek, actually used 20% less data. It is an architecture that is 80% more efficient to essentially build a model that acts almost on the same level as Claude in terms of coding and in terms of open-ended question answering. So what we are really looking into here is that we are slowly moving away from a brute force approach when it comes to throwing a lot of hardware and throwing a very large architecture onto the problem to more mathematical foundations and making more, let's say, nitpicky choices and working around certain constraints. So these constraints being the largeness or the, let's say, size of those models, the data that is being consumed, and also the specific, let's say, GPU that we are using. Because there are multiple companies right now moving away from the NVIDIA's, let's say, perspective into GPUs and using things like light-based, photon-based computing, which actually uses much less energy and is actually more sustainable in the long run. So there is a sort of a balancing perspective that needs to be taken when it comes to what are the exact constraints around which we are looking into building these systems. But for example, when we build the AI systems that we currently have ongoing in Polygraph, we're looking into making sure that we are attacking the problem from a perspective that is going to reduce redundancy. We didn't want to use large language models because they sounded fancy. We want the right tools, the right architecture, and the right data set that would enable us to not just throw very large quantities of data into the model, but just have curated data sets, less processing, a smaller model that requires less training, and also, it gives more power to the end users. So there are multiple perspectives I have essentially elaborated on here, but that is my 5 cents, let's say.
No, that's great, and I think we are generating a lot of interest. There are even more hands coming up, and I think we'll try and go in the order I saw them. So, Lance, you want to go next?
So thanks. Basically, just to answer your earlier question, I'll also put my other hat on as working for the Research Foundation for SUNY. So if SUNY is the State University of New York, we have 64 schools, 500,000 students. You can imagine a school for everything. And in tech transfer, which is one of the areas I work, the greatest emerging asset for all of the schools in America, not just us, is our data. We have many people approaching us to get data sets from us, whether it's medical or testing or even student data or other data. So it's actually becoming a leading asset very quickly for the university systems to be able to sell and give that access to. So I think when we touched on that, that's going to be yet another driver going forward, as it's almost like a natural resource like oil or something, where if you have these fountains of data, as one quick example, I'll go, but is that we've had people come and ask us for our failed pharmaceutical data, like experiments that didn't work. And like, why would you want that? Because, it's valuable to an AI or something, because it could figure out what you might have done wrong. Oh, okay. So anyways, so you're really touching on something that is emerging quickly as an asset class.
Yeah, it's interesting. I hadn't really thought of it from the legal perspective as an asset class, but there's something interesting there for sure. Giovanni, want to pop over to you?
He's just had his hand up the whole time. You didn't realize it.
Oh, sorry. I thought it came back up again. But nevertheless, if you want to join in, you're welcome to. If not, we'll pop over
I have nothing to
Dr.
add.
Satyam.
I have nothing to add.
Very good. And then in that case, Dr. Satyam, over to you.
Yeah, so the discussion we had is really good, great. But in practical sense, we all end up doing what is called proof of concept, right? And that is where I think a huge amount of energy is wasted in terms of leveraging the data. You see, the concept of AI is well known, concept from value from data is well known. What people need to really do is actually take advantage of what has been done by others and minimize the effort to actually build the models that are essential for their business problem. If you focus on the business problem, then this whole concept of cost of data storage as well as energy consumption reduces significantly, right? So for example, I'm talking in terms of a energy company, and without naming any names. If we are actually consuming few petabytes of data, and let's assume we have built 6 or 7 different models, and that is done by company A, and we know that for a given problem, and these are very scientific and engineering problems, at least 3 of the models are not even relevant, because just because you did an academic exercise and you used certain models, you actually unnecessarily wasted energy. Now, the second company goes saying, oh, in order to compete with that company, I'm going to still run the same models. We know that science doesn't work that way. That particular methodology or that particular model is not appropriate for this kind of business problem or scientific problem. Why do run it? So people really unnecessarily create more work and spend a lot more energy and actually create the data storage problem too. So I think one of the things that in businesses, we really need to know what business problem we are solving, and then actually implement those solutions based on what others have done, and then do minimal work.
Dr. Satyam, don't you feel that this whole thing is an academic exercise for people that are running the LLMs? Their goal is to move artificial intelligence to artificial general intelligence. Now, I know that at SUNY, where Lance is, they have a complex systems research institute run by Hiroki Sama. A lot of the work that's done in complex system is about especially the storage of information in the human brain or consciousness. When do we choose to keep things? When do we dump that stuff away? And what's actually necessary for us to do higher level processing? Now, we haven't figured that out, but we continue to run down this path of an academic exercise to say that we're going to get to artificial general intelligence. We're going to fix this data storage issue, but they don't even understand how the data storage happens in the mind. So to get to the general intelligence of a human being, you would have to understand how human beings are really storing these things. And this is still a mystery to some of the brightest minds in the world, frankly, that work in complex systems. So to me, the whole thing feels like a non-starter. Whether it be energy or anything else, you should know that it's not worth the investment until we can really understand fundamentally how human beings think and choose to prioritize data and the value of those elements. And Lance, to double down on another one of your statements, it's a dark and scary path to hold a bunch of that data which you have, but you really don't have the rights and permission to it, and continue to treat it like an asset which you think you can monetize. That won't go well. And I will share that some of the major 7 and even Fortune 50 firms in the world are trending away from that idea and moving towards one where the consumers are empowered and requesting the permission from them. And to clarify a statement even further than that, many people say that data is an asset, which we know here in this group it is. And so when you choose to store it, how you store it, how much of it, the energy to store it, much like gold or oil, there's costs involved. But to truly treat it as an asset, it has to be recognized by the Internal Revenue Service, right? It has to be a part of the tax code which somebody can deduct on their balance sheet. And so when data moves to that point, then you're going to start to see interesting efficiencies and open up arbitrage opportunities for people like Giovanni to actually trade against something like that. But that whole thing is going to be beholden to the fact of people, human beings, taking their data, which is compartmentalized to them, and permissioning it in a longitudinal format and sharing to a point where we can really understand how data storage should happen, because it needs to mirror what happens in human beings. We're those most efficient systems to look at. So in order for us to solution our future, I don't think it's so much of an engineering problem, but really a study of human beings globally in the most diverse format possible. I think that's where we're going to find our solutions to data storage.
If we go into the human side, I think it gets very complicated very fast. We probably need a separate panel on that discussion.
Yeah,
And then we can bring biocomputation into it.
Mm-hmm.
And then we can discuss how such a small system can store so much information compared to what we are building. So I think that could be a separate panel some other day.
Yeah. And question for Togrul on your data, the data intakes that you do. How are you folks considering data provenance in the storage aspects of the data which you guys are processing on top of? I know that's a big part of your quality measures and risk determinants through Polygraph and your technology, but I want to understand from that aspect, where if you're looking at data storage, you can either store something stolen or you can store something that's truly proprietary and owned by that person, right? What's the provenance of those things?
So here at Polygraph, the conclusion we have reached to is that we actually establish the provenance and privacy of the data by making sure that the data does not actually leave the premises where it's supposed to be. For example, if company X is today trying to build models, or perhaps trying to send the models, their data, to some other company to train their models, right? In that case, we provide the tools so that they can essentially remove all the confidential data that they want out of their data sets before even sending them to the outside sources. So it's like any third-party company will not be getting anything confidential from the initial company X. Now, this actually ties back to us as well. So you could ask the question, how do we exactly make sure that our models understand their complex and confidential data, right? So we offer the services for the people who have the resources to actually train their data, either on their own on-prem servers, or to train the model, to further fine-tune the model on their own VPSs. So it's like virtual private clouds. So this is really virtual. If you want full protection from outside sources, you can further fine-tune the model on your own servers. If you're all right with essentially sending that to a cloud server, a cloud service, you can perform the action over there. But under no circumstances do we serve a fine-tuned model, fine-tuned for company X to company Y. So that model will live inside their premises and will be only working and serving them. So that's essentially how we deal with all of the privacy and provenance issues, because the data does not leave the premises in any case.
Very cool.
Yeah. And actually, we have established systems where people can make sure in-house that their data is actually quality controlled for consumption by other models and other models as well. So it's like really we've decentralized the tools necessary for our workflows and for the workflows of third-party companies to make sure that the initial company that cares about their privacy can establish the privacy of their data sets.
Mm-hmm.
Yeah.
One comment.
So actually we did. So just a closing, let's say, sentence here. So we did actually a lot of studies on how we would like to, what angle we would like to pursue on this, and we talked to a lot of people. So most of the companies, you may not perhaps believe this, but do not really want to share data even with the cloud service providers. So to the points to actually reestablish the points that have been made during this conversation, cloud is not really secure. And most companies do not really want to keep things on the cloud. So this actually raises the question, okay, around, let's assume that 40% of the data that I have is, let's say, it overlaps or correlates to the data that Alexander has or Lance has, right? Would it benefit us to store 40% of that data, which is very closely related to each other on a cloud server, where it's centralized rather than have multiple copies on it? So that's a different sort of angle that would require its own conversation.
Mm. That's also beholden to communication between company A and company B, which currently doesn't happen. And goes back to my original point of intellectual property protection and people not wanting to co-opt, like Dr. Satyam had mentioned.
Precisely, and that is the reason why we are hosting the data on the
also data provenance. Data provenance gets very interesting when it comes to machine generated data, right? One is the what I call automatic machine generation, like say IoT devices and things like that. How well those devices are being trusted from the field, and if those devices, they get even more complicated if those devices are actually running on the edge machine learning models. Now think of it like I installed a model today, and Alexander goes and modifies the model, and without changing the version number of the model, so the output doesn't actually say whether it is using my model or is actually using Alexander's model, right? Now if the model predicts a completely different result, is the data gone wrong or is the model gone wrong? So when it comes to field operations, there are a little bit more complexity in terms of data provenance, and of course, model provenance is associated with it.
Very good point.
I would actually like to elaborate on that a little. So to build on the, let's say, point that I made earlier, at Polygraph, for example, we provide a certain tool, AI detection tool, that not only detects whether a certain, let's say, content is AI generated or not, but also tracks the potential sources of data used as training data for this model to essentially come to this conclusion or generate these sequences of tokens. So that actually, in a way, solves some part of the problem, because you can see that, okay, this generated data, just because it's generated by this model, it does not mean that it is owned by this model or owned by the producer of this model, right?
That's
So,
correct.
yeah,
Togwell,
in that sense,
we double down on that.
yeah,
And to make your example legitimate, you're doing the analysis. We pass a tokenized identifier as an audit trail for every piece of data that a human being chooses to store in the vault before it gets permissioned. So wherever it floats out in the electronic ether that is out there, it can always be traced back to its use at a date timestamp, serialized to that person in their account to say that they're the actual rightful owners of it, which would make your job and your systems a hell of a lot easier.
that would be correct.
Yeah.
And actually, give a peace of mind to the consumers as well,
Mm-hmm.
in the sense that they would see exactly who to trust. And if they have the opinions about what sources they are consuming, then they would be given the power to essentially selectively ingest information.
Correct.
So we're running a little short on time. I think that we have kind of over the course of this panel hit on a lot of topics, many of which really could be their own, certainly their own panels and possibly their own dissertations, maybe even their own companies. But I think from my perspective, the interesting thing that I'd like to hear from each of you, kind of at a 1 minute each as we round this out, is for our audience in Davos, for the people who are watching this, who are not AI experts, who are not data experts, who are not energy experts, what's the one thought that you want them to take away to go say, all right, I need to think more about this. I need to read about this. I need to understand this better. This matters to me and the world and what I'm trying to do. And I guess maybe we'll just go right to left on my screen because there's no particular reason. We'll start with Rahul.
For me, I'll say our biggest concern is use of energy. And how can we reduce the energy as the time keeps on going up? Data is going to be, like everybody said, there's a lot of redundant data in the marketplace. One of the laughing things with us is people put the data online, store it, and 60% of the data is never ever looked back. It's unusable. So what do we do with that kind of data? The secondary issue always comes is as the computing power keeps on going up or GPUs keep on advancing, where are we coming up with the energy resources and the cost to run these kind of operations? Like some of the panelists said, it's more of academic than business. It has to be looked at from the business standpoint of view, how it makes sense for a business purpose more than academically. That's where my biggest point, I'll bring it out to this panel.
All right. Amanda, over to you.
Yeah, I think one of my original points is, especially for consumers or potential like enterprise customers, I mean, what type of AI is really practical for their use cases? Do they need a 7 billion parameter model that's going to potentially hallucinate on outputs that can be very important for them? Or is it more effective to use, something like a BERT model that is much cheaper to run? And either way, from my perspective, for compliance purposes, a human still has to review the accuracy and output. So yeah, it's really just what's going to work for their use case.
Makes sense. Togru?
Yeah, on my end, it would be that for any customer or consumer or large scale organization, I would ask them to stay vigilant and curious. What I mean by that is to understand and analyze the systems that they are using, to understand and analyze the potential privacy and provenance issues, and to really dig deep on whether they need the technologies that they are trying to employ or not, and to understand that the technologies they are using also contribute to the carbon footprint that they themselves are contributing to.
All right. Alexander.
I'd just say in 30 seconds that for the people who watch us in Davos, resource holders, your vision for a future will be short-lived unless you all choose to take a unified cooperation strategy, especially for your investments in your systems. And when you choose to deploy your capital, deploy it into things which are decentralized and human first. Because if you don't do that, you'll never be able to win with a technology first approach, especially when humans are the ones who design it.
All right, and Lance?
For those who aren't familiar with our area, I would just basically say, watch this space. As you can tell from all of our conversations, it's unsustainable. We have three exponentiating, hockey stick problems at once: production, storage, and actually cybersecurity. We didn't touch on that really at any level. And everything's got to change in one direction or another. Perhaps it's the architecture, perhaps it's the technology like photonics or something that's a very different energy platform and things like that. But something's got to change, because we can't keep down the same path it's on. And it's unrelenting, and so it's not going away anytime soon. And the last point is that you're literally bringing on like 3 Mile Island back for power for this problem. So that should tell us, we need to look in the mirror and say, maybe we should do something different. So my 2 cents.
And Giovanni?
As Oscar Wilde says, people know the price of everything and the value of nothing. So I would say you denote how valuable something is by more accurately pricing it. And I think that data is extremely valuable, but it's hard to figure out its value when you have venture capitalists willing to flood money at a opportunity, mispricing it. So I think that data and data centers and power costs, I think power costs are the most fairly valued of all the elements I just discussed. But I think that we're going to go through a seismic shift and tectonic shift in the establishment. And so we need to be very dynamic and looking forwards at the future.
And then last, but certainly not least, Dr. Satyam, please bring us home.
Yeah, I think number one, as Alexander said, look at what is important. That means do it in the right context, in the right place, with human in the mind. That is very important, because technology first is not this only solution for most of the businesses, because that has taken us to always the wrong path for many companies. And I think time is there to course correct this, in the sense that we can actually have resilient businesses and greater employment for our people, and healthy employment for our people for the right reasons.
Thank you, Dr. Satyam. Appreciate that.
And thank you to the entire panel for joining us and providing your really interesting and valuable insights. Hopefully our audience in Davos is going away and scratching their heads a little bit and thinking, hey, maybe I need to dive into this stuff a little deeper and figure out where we're going, because these are important and weighty topics. Thank you, everybody, for your time. Much appreciated.
Thank you.